Hello, hi everyone, and welcome to this webinar. Today, Xavier Hallade is going to speak to us about user experience guidelines and best practices to develop compelling applications with the Intel RealSense. On the right-hand side of your screen, you will see a chat box. Do feel free to use it, ask any questions you're asking yourself, and Xavier will make a few stops during his presentation to answer them. Xavier, I will let you now introduce the two questions we have, and you can start the webinar.
Sure. Hi, everyone. So right now you'll see a first question. You get around 20 seconds to answer. It's for me to better adjust the content of the following presentation.
Okay, so first question is, do you own an Intel RealSense camera? So you have a few questions to answer it, and then it will disappear from your screen.
Okay, almost everyone answered. Thanks. It seems half of you do own a camera already, and the others mostly are interested, and quite big number of people don't know much about RealSense yet, so I'll have to go through the basics again. Here's the second question, and we'll get started.
So second question, are you familiar with augmented reality, virtual reality, or 3D design?
Okay, almost everyone voted. Thanks. Okay, so let's get started. So welcome to this webinar on designing better user experiences for Intel RealSense applications. So we'll talk mainly about the F200 camera. So some of you weren't exactly up to speed with RealSense, from what I saw from the poll. So the F200 camera is the RealSense camera that is designed to be integrated into laptops, all-in-ones, and also some two-in-one. So it's mainly to be present at the top of the screen, like a usual webcam, and for screens that are at least 13 inches or more. So usually more around 14, 15, even 17, or with the case of all-in-ones, 24 inches, 23 inches. So that's very different than for tablets, for example. So we'll go through around examples. When you develop a RealSense application, you really need to understand the strength of all the modalities you can use for RealSense, why you should use it, in which case you should use it or not, because it's not exactly meant to fully replace keyboard or mouse or touch, of course. Or you should minimize user fatigue, and we talk also about the precision and the quality of the data and what you should do with it, and also about visual interfaces. So we'll have time for questions in the end, but during all the webinar you can shout a question in the chat box and I'll try to answer it if I see an opportunity to do it. So I'll repeat the question to everyone and answer it after. So with RealSense and the F200 camera, you have many capabilities provided by the SDK. So you have speech, hands, and face tracking. These are the main ones. So all these modalities, of course, they have strength and they have some drawbacks too. So for speech, of course, it's compelling when you use things like Siri or Google Now. It can be really cool. When you're in front of a computer, sometimes you're not alone, sometimes you're in a noisy place. So you need to take into account for all the environmental noise and all the things that are happening around the computer. So when you design for speech, a good thing to do is not to listen to all to to be in free dictation mode and try to understand sentences, the best you can do is, for example, to use grammar. So this is provided by the SDK. And when you use a grammar, you can recognize specific words or sentences that the user are saying. So, and grammar is a lot more reliable. And plus, on top of this, if you want to have a really compelling experience around speech, you can also couple this with face tracking. So, for example, you can listen to the user only when he's actually facing the screen and moving his mouth. It's even better because so this will be improved a lot, speech interaction with computers. For hands is of course one of the biggest usages with the RealSense F200 camera. And to design for hands tracking, you really need to understand the field of view of the camera and some common issues with hands gestures such as occlusion and others. I'll talk more about this later in the slides. But yeah, hands allows for really rich and engaging interactions, and they are really cool when you can really have a feeling of direct manipulation. But you should try to design the interaction so the user don't need to make really large moves and really high, because it can be tiring, and when the hands also goes out of the field of view, that's quite complicated, so it can be problematic for the user. And then you have the face modality from the SDK, so you can sense natural expressions, emotions, and of course the 3D position of head. So precision of 3D tracking is really good, it's working well. When you want to track natural expressions, such as the openness of the mouth, smiles, and overall emotions such as anger and others, which are all provided by the SDK, you need to take into account that there's a large variability of these expressions across ages, cultures, personalities. So when you design for for face emotions and expressions, you should really have calibration phase, so to properly adjust what you're tracking to the users. Of course, you have already existing ways to interact with computers, so such as touch, keyboard, and mouse, and all these are not going to disappear right now and be replaced by RealSense. So it's better to really design your applications to take advantage of all the ways user can interact with your computer. So touch is really good for 2D interactions with direct feedback, so you get an actual tactile feedback, which you don't get when you wave your hands in mid-air. So sometimes touch is best, and keyboards allows for quick entries. Of course, for text is quite useful, but also for commands. But if you go to shortcuts and all this, they are not always intuitive. And then mouse is perfect for 2D interactions. That's quite obvious. Mouse is not always there, so on laptops sometimes you get a touchpad instead. So consider sometimes if hands tracking from RealSense can be a big improvement over the mouse, but sometimes you will need to redesign your application so it's more suitable for RealSense interaction. We'll have more examples later in the slides. So when you want to use RealSense, you need to have some sort of checklist. So first, why would you use RealSense? So in which way is it improving the interaction than just with a touchscreen or a mouse that are common these days? So whether it's better because you have free interaction, or because it's more, it can be more intuitive, or the user can do this in more lazy position, for example, for DVD play, for video player or PowerPoint slides where sometimes you're not just next to your keyboard, so you may want to do RealSense gestures so the user can move the slides from away of his computer. So if you want to integrate hands tracking, how can you do it so it's not a pain? I mean, it should work well. It should be reliable, and the user should expect it to work. And for this, I've seen many developers directly trying to use the raw data from the SDK, so the position of the hands with everything tracked with all the gestures. And of course, it's data from a camera, and it's working in environments that are not always perfect. So when you deal with this kind of data, you absolutely have to smooth it. So even the SDK is providing you some filters from the PXE smoothers. So it's part of the documentation. Just put it up. So you have a smoother utility and accessible from PXE smoother, and it's providing various ways of smoothing data. So if you're designing interactions with hands tracking, you absolutely have to smooth one way or another, whether using our own smoothers or your own smoothers or the one from Unity or whatsoever, but it's just mandatory. You can't expect a really good interaction if you don't do any smoothing. Then the user also needs to have a direct feedback. So when your hands are in air, it's not like a touch screen, so you don't have a tactile feedback. So sometimes it can be complicated to be precise and to really know what's happening. Plus, you have the issue of the field of view that is not as wide as some user would want it to be. And someone is reporting is not able to hear anything. Can someone just shout a question saying he can hear? Okay, thanks. Thanks. So I'll go ahead. Someone got an issue with his own laptop, so sorry for him. So when you design with RealSense, you need to design for ease of use. So it shouldn't be complicated for the user to use the RealSense part of the application. If it is, maybe the application you're working on is not really suitable for RealSense. That happens. Not all apps are meant to be used with RealSense. You need to understand the capacity of the technology. So for example, I've seen many projects of people trying to re-implement sign language recognition. Sign language is something quite complicated, so unless you're just a machine learning guru, I would say just don't try it. Plus, when sign language, so alphabet is something maybe easier to understand. It's certainly possible with our camera. But for alphabet, it's better to use a keyboard. And if you want to go to full sign language recognition, then you also need to get facial expressions, and all the signs are usually drawn in a wide space, so going far away from the field of view of the camera. So that's quite a limitation, and that makes it complicated for this kind of recognition. So really, when you first want to design an application, an interaction, or implement an idea, you should really have a look at how the camera works and to see if the gestures you want to implement and the interaction you want to implement is possible, considering the field of view of the camera, the occlusion. So I'll talk more about occlusion a bit later, and the quality of the data. When designing interaction with hands, if your application is meant to be used on a long period of time, you should design it for breaks. So the user shouldn't have to be like an hour with arms in the air. with hands in VR. That can be very tiring. Also, you can, if you want long interactions, you can also focus on interactions happening near the bottom of the field of view, so the user don't have to lift his hands too high. So the kind of gesture that's pictured on the top right of the slide, for example. So left and right arc gestures are really easy to do, even for really lazy people. They are not tiring at all. So if you can design your interactions for this kind of gestures, I think that's the best. Also, in many cases, it's really better to design for relative interactions instead of absolute interactions. So, for example, when it's relative, you can have quite small moves that will be reflected by big moves on your applications or on the screen. And that's a lot better, because with absolute motions, you may face the issue of the user going out of the field of view many times. And also you'll face more the issue of occlusion. So when the hands gets just in between the user and the screen, so he doesn't really see the screen anymore. So in many cases, relative is way better. Plus, if you design for relative interactions, for example, you can decide for a specific state of the hand. So for example, when it's a fist, you start the interaction. And when it's fully open, you stop the interaction. And that's quite easy to develop for, and that doesn't require, that's working reliably, even with that noisy data. In general, don't expect a really precise input from the user. So again, smooth it. Use the PXE smoother utilities if you can. You should always smooth it, and in the way you design your applications, just don't design it with really small targets or to reach with the hands or things like that. Like the keyboard with hands gestures is one of the worst example. You should really not do that. When you use the camera, you need to, with hands tracking, you need to remember that the speed of movements you're expecting may be problematic depending on the modality you're using. So especially for games where you expect people to really wave their hands really fast, very quickly, then it's not always possible. So if you do really the full hands tracking with the 22 joints and all the gestures, actually it's documented, so let me pop up documentation. Then it's really low speed, so it's less than 1 meter per second, and this is problematic for games. If you lower the resolution, so cut the field of view in half, you can reach 2 meters per second, but that's not really suitable to always cut the field of view. So the best you can do, especially for games, is instead of relying on full hands tracking with the 22 joints, is to track the hands in extremities mode, or even better, in blob mode. So the blob mode is one of the most reliable input methods with RealSense SDK. Plus, it's not consuming much CPU, and it's just reliable. So let me directly pop up the example from the SDK. So it's the blob module viewer. So here you can see I can track hands, I can track points, I can move really quickly if the frame rate of the webinar allows you to actually see it. You can see the closest point, it's always tracked reliably. So if you only need the closest point of the guy pointing at the screen, just use blob module. It's a lot more reliable than tracking full hands. If you don't need full hands, just really go with the blob module. Thus, the latency is just quite perfect, actually. So you can see on the right side of this sample how you can access blob data and what are the parameters. So you can track up to 4 blobs. You have built-in smoothing, and you can track, like in extremities mode for the hands, the closest point in red here, the center point of the shape that's tracked, and left, right, top, and bottom points. So left, right, and top and bottom points can move quite much on the blobs, but they can be useful, for example, to determine if the user hand is open or if it's a fist, for example, depending on the space between them. So you should play a lot with blob modules to design your interaction with games or applications in general. Especially if you just need 1 point from the user, then blob is really the way to go. Plus, with blob, it's just not tracking hands, it's tracking objects that are close, so you can really track anything, so even a stick or whatsoever. So that would allow for more precise interaction from the user. So there's a question that's quite up to the point. So can you still get the finger foldedness data in blob module, or is that only available when full joint tracking is on? So the blob module is actually tracking objects, blobs, things, and not hands. So you don't get any hand-specific value like openness. If you want to determine the openness of the hands, you can still track the distance between the topmost and the bottommost points. But you need to also pay attention to the fact that sometimes elbow can come into play. So even better is the distance from top and bottom to the actual center point. This will be more reliable. And then you can determine if the end is fully closed or fully open, even if you're actually tracking an object. So back on the field of view issue, so here's a artistic view of the field of view of the camera and of the user should interact with it. So if the user is reaching his keyboard, the end's going out of view. So same for the table and everything that is right down. And when you design interactions, the field of view is not that wide, so it's quite common to have the user going out, especially if you have absolute tracking, because the user will always want to reach the hardest point, the point that is the hardest to reach. And the thing is, when the end tracking is lost, it can take seconds to get it back, because there is a calibration phase. If you're using blob tracking, that's less of an issue. Also, cameras are integrated in laptops and all-in-ones, so the placement is not exactly the same. In general, that's fine, but you should still test interacting with your applications from different angles. That's especially important for example, the pitch of a head if you're doing head tracking in games. When it's used on a laptop, the pitch will be always facing a little bit down, and for all-in-ones, that's more straight. So I've mentioned occlusion like 4 or 5 times, and it's still true. So here's a picture defining what exactly is the issue with occlusion. So when you design hands tracking and you replicate, and you expect the user to interact with something on the screen, pay attention that you're not asking the user to actually place his hands exactly between where it looks and the screen, because it will not be able to see it actually. That's why it's always better to design for relative motions. So you start a gesture somewhere and it will be relative to this position, or else you can have absolute tracking, but starting with a zero that's not exactly at the center of the field of view whatsoever, but more on the right bottom side. But I would really advise to go for relative motions if you can, because it has many other advantages. And more generally, since you don't have really the feedback you would have with a tactile surface or anything like that, it's really important to provide feedbacks to the user, so from the screen. It's really important to design the UI so the user now that is actually interacting with the application, and to know what he's actually doing with the application. So he's actually scaling an object. You should have arrows, like when you scale a window with the mouse on Windows. And you should also have good feedbacks for warnings from the system. So the RealSense SDK is already providing warnings. For example, if you're doing head tracking, you'll get warnings if a head is going out of the field of view. If you're doing hands tracking, you also get warnings if they go out of the field of view, if they are too far, and so on. So we use these alerts. So these are called alerts inside the SDK. We use these alerts to give a feedback to the user, and to ask the user to go back inside the field of view or to avoid going out. So a good thing you can do is to just have an overlay in background of your application showing the user. So if you really want precise 3D interactions, so the user exactly know what the application is seeing, or you can put a small viewport on the bottom right. So in this picture, you can see the full user with tracking, but it's not necessarily, you don't necessarily need to put the whole user in there. If you're doing blob tracking, for example, putting the blobs is enough, so the user knows what's actually tracked by the SDK, and that's enough to get a good feedback for the user. So yeah, you can put some distant prompts, you can put diagrams to explain to the user where it should be when you first try your application. Same for action. So I've mentioned the idea of if you're scaling a window, you should show a scaling icon when the user is actually performing the action. And it's same for pressing or hovering any objects. Sorry. The user should really know instantaneously what he's doing with his hands, so how the application see what he's doing. So it allows the user to really easily adjust his interaction and to avoid any really big troubles. So I know that's a lot of work to implement all feedbacks and into applications, but that can change the interaction a lot, and you can't expect the user to follow like a 10 minutes tutorial on how to interact with the app and a big training phase. That's not possible. But if you just add some good visual feedbacks, the user will adapt really quickly. So again, on lens tracking, if you want to implement full 3D interaction with objects, consider the size, the placement of the screen on the screen to avoid occlusion. You should prevent the user to have to reach the edges of the screen because then it will go out of the field of view. And again, you should smooth your data so to avoid failures of tracking. So it was quite much on hands because I think that's the most complicated way of interacting. So way of getting data from RealSense, but that's also one of the most compelling ones. Here are some general guidelines. So it's better when you first laundry application, so when the user first launch the application, to teach him what he can do, so how he can interact with the system. So it can be from just diagrams and quick words, but since there is no direct feedbacks and moving hands in VR is not always something common across people using applications, you should tell the user about it. Then try with real users. So if people worked a lot with RealSense SDK, we tend to make the perfect gestures that are recognized by the SDK. But users are not all equal. They don't all perfectly know how to do some specific gestures. So you may want to do a little training phase still and test your app with real users, so other colleagues or anyone you can find. So then there's a quick checklist. So when you implement a RealSense interaction, is the action to be performed better with other modalities of interaction like touch or mouse? If so, maybe you are the gestures from the user precise and critical. So if you want to do something like remote surgery, maybe you should reconsider because you will always have data that is not always 100% accurate. That's the thing. Where you are interacting with physical camera, light, and it's not 100% precise. You can't expect it. Plus, waving his hands in the air recognition only when the user is actually facing the screen. I think that's kind of good opportunity to use more than one modality and really improve the results because of this. If interaction has been implemented already by someone else in our games, try it and see if it's working first. I think it's best, and see why. What are the issues with it and how you could improve it. So in the end, before releasing, so check that for the users it's easy to get on board with the new features we implemented. If there is feedbacks on, especially on field of view issues, so if you're getting alert from the SDK and reflecting this to the user. So if your UI has been properly designed for interactions that are not 100% precise, and if you don't need the user to have the hands in VR all the time, unless it's a short game, in that case, that's perfectly fine. And test with real users first, no, not only with developers who worked with the SDK a lot. So yeah, this was a demo of Move It game. On the webinar, it's a bit complicated to show video, but with this one, it's using the blob module, so it allows for really quick interactions. The user has been placed at the top left of the screen here, so you can directly see what the game is seeing. So it allows for really quick interaction because blob tracking is really quick and easy to code with. So this is the end of the slides part. Here is a link. I will copy paste it into the chat box, I guess. These are links to PDFs with all the guidelines we have for RealSense user experience. I'm going to copy paste the link directly in the chat box. It's something you should really go through if you want to design apps that are using RealSense. Yep, here it goes. So we have really huge set of guidelines. And now I'm going to look through the questions you had and I haven't answered yet. In the meantime, you can shout more questions. We have around 20 minutes left, so that's plenty of time for questions. So one of the questions was, what kind of processor is used by RealSense? So inside the camera module, the F200 one, there is an ASIC that is doing that is generating the depth information from the cameras that are on board. And then all the hands tracking, face tracking, all the recognitions are done by the SDK on laptops and all-in-ones. And these computers are embedding core CPUs from at least Haswell generation, the 4th generation of course. So computers from 1 year ago and subsequent ones. The question was, what's the speed of capturing the camera? So in the camera, the depth stream is being recorded at 60 FPS, and the RGB stream is being recorded at 30 FPS. So for modalities that are using both RGB and depth, it will be of course limited to 30 FPS. Another question was, who is BMAP and why did you give this seminar? So BMAP people are here and maybe can answer, but I can do it quickly too. So BMAP is an agency Intel is working with, and I am personally working for Intel, and they coordinated and advertised the webinar and did all the logistics. And they're organizing regular events Intel is participating in. So meetups and over.
Thank you for the introduction, Xavier.
You're welcome. So someone had an issue with built-in gestures from the SDK, for example, air taps. So air taps has been introduced not so long ago, and like many gestures, sometimes it's hard to make it recognized. To really have a better recognition of built-in gestures from the SDK, I would advise to limit the number of gestures you want to recognize and tell the SDK about it. So in the SDK, you can enable gestures one by one, or you can enable all of them. So don't enable all of them, but instead recognize only a bunch of these. You'll get a much better recognition. And then some gestures still need some learning curve, some learning from the users to do it well. I think tap is one of these. And most gestures are also designed to be done in front of the camera, so not really from sides and so on. So if you're expecting the user to do taps in many directions, it may be complicated. So you may have to think again of when the user is expected to do taps, or to maybe reconsider how wide the movements the user is doing should be. So again, we're back on the advice on doing more relative motions than absolute motions. Someone is asking for, I think, hardware samples. So to buy the camera, everything is available on Click, which is our shop. Let me just find you the link. So here it is. It's in stock. So it's on click.intel.com, and you can just look for F200 actually on Google, and you will find it. So another question is, how is this different from Kinect and Leap Motion? So first of all, Kinect is a big module, quite expensive. You can attach to computers, so it's meant for more long-range interactions. If you take Kinect version 2, it's also working for close interactions, but again, it's really heavy and it's draining a lot of power. So the big difference with Kinect is here it's only close interactions, and it's starting to be integrated into computers. So with low power, and that's different kind of interactions. And we're aligned with Microsoft. So if you take, for example, the next version of Windows 10, on RealSense compatible PCs, you get a feature called Hello, and that allows for really quick and secure facial login, face login to Windows. And it's compatible with all the RealSense camera. It's done by Microsoft. And for Leap Motion, so Leap Motion is working in different ways. So their camera is facing up, and they are doing the recognition from two RGB and IR cameras, if I remember well. So it's a bit different technology. Sometimes it's also suitable for some projects. However, I know about integration of Leap Motion in only one computer. I don't know of any other, so it's still quite an external hardware module. So quite many questions. Any plans of using the GPU in later versions of the SDK? So some modules are already using the GPU through OpenCL. I don't have the exact list in mind right now, but yeah, we have big plans to always optimize the SDK, and some part of these are going through OpenCL and GPU usage. So not all modules are using it right now, but for those who aren't, are still performance constrained. That's in the plan. That's in the plan. The question was, what happened with 4 swipe gestures found in the old SDK? So last year SDK with all the camera, because they worked really well. So right now we've reintroduced the swipe, all the swipe gestures, like swipe left, swipe right, swipe up, and swipe down. I'm not so sure about swipe up and down actually. Yeah, they are not working that well with the current version of the SDK. I mean, they are working well once you know how to do this. So in my view, they are not working that well. So that's a bit unfortunate, but yeah, swipes are really complicated to integrate if you want to really differentiate between swipe left and swipe right. Because from the point of view of the camera, if a user goes out of the field of view or just do one swipe left and one swipe right, it's really hard to really know what the user is doing, if it's a swipe right then swipe left, or if it was just a swipe. And depending on where the gesture starts and it ends, it's complicated to get it right. So for some specific use, you can, if you have, for example, for a PowerPoint viewer, if you just want to have a simple swipe and you don't want to track the hands for doing anything else, you can re-implement the swipe yourself, like the hands goes from the right to the left side and disappear. And that's only if you want an interaction that is really specific, so only swipes. Then you can use both modules. But for the full gesture recognitions, yeah, it's especially complicated to make it work because people may want to do swipes really quickly. But when you do the full hands tracking, it's limited to less than 1 meter per second, and it needs all the field of view to be operated. So that's quite sad actually, but I would recommend not to use the swipe gestures from the SDK right now. So another question is about the megapixels of the device. So the depth stream is VGA and the RGB stream is full HD. Another question is about Linux supports. So on Linux, I've heard about a driver made by an independent guy, so totally independent from Intel, and it works. So you can go ahead and try it for the F200. However, we don't provide a driver ourselves, and the SDK is not compatible with Linux. So we know it's interesting to some people, but unfortunately we have other priorities right now. Someone would be interested in getting access to Hello now. I don't know how you can access to it publicly yet. Maybe in the latest builds of Windows 10. Yep, you'll have to check, because maybe the new DCM will be distributed through Windows driver, so you can trigger Windows Update to check that. Else you should wait for another release of the DCM, which I don't know when it will happen, or maybe I just can't say. So another question is on when I'm operating from, maybe Hi or all the RealSense teams. So RealSense teams are based a bit all over the world. Many are in Israel, many are in the US, some others are in India and China. Myself, you can guess it from my accent, I'm based in France. On the compatibility, is it only usable on Windows 8? So yes, the SDK is only usable on Windows 8.1, 8.1, and 10. Our question is, we got so many. Is it possible to integrate two RealSense cameras and get better tracking? So the F200 is meant to be integrated as the one and only camera in the system, so you shouldn't do that. However, it may work in the future. It's something we are looking at, but not to be integrated, but for more specific projects. If you want to use peripheral cameras, it may be supported when there are another. You can try with current versions of the DCM. Maybe some things are working, some others aren't. In general, you should know there may be some crosstalks between cameras, but you can configure this to emit different patterns and so on. Are there any plans of extending product range of laptops and tablets with built-in RealSense cameras, especially in low and mid-cost segments? So for low and mid-cost segments, there is one issue is the cost of the camera module and the chip you need to operate it. So for cameras integrating into laptops and smaller devices, we'll have the R200. And we will try to reach like the lower cost we can, but the decision is up to OEMs. If they want to pay the price for a feature also in low and mid cost segments, and that's not sure about that. I'm not sure about that. So there's a question about the challenge, if there will be a new RealSense challenge this year. I honestly don't know. I'm not organizing the challenges, and yep. One of our comments is F200s appear to have affected badly each of our scanning activities. Yes, that's possible, especially if you're doing scanning. You should look into modifying the profiles of the camera so it can emit different patterns. Because right now in the SDK, I think you can emit 6 different patterns, and you should emit different ones. So there is not as much crosstalks as you would want. Our question is recently compatible with mobiles, so iOS, Android, and Windows Phone. We officially have plans for Android, and you'll get more information on this later this year. We have already shown prototypes of actual phablets running on Android, 16 inches phablets with built-in R200. And they're working quite well, so I'd be glad to see it on the market from OEMs one day, but we don't have any ETA for this, of course. Another question is again on the extremities mode for hands tracking. So in full hands, we are tracking the 22 joints, and we have the openness of the hands extra. In extremities mode, you only get the extremity points and the hands alerts, but you don't get the openness of the hand. Okay, I don't get any more questions. I've went through all the ones I had. Thanks for so many questions. I only had one last comment of someone who is actually attending this webinar from his home, and it's 4 a.m. There, so congrats, honestly. Thanks for attending this webinar.